Assalamu alaikum. Today I am going to explain retraction theorem, no retraction theorem basically. So the statement of no retraction theorem is there is no retraction between B2 onto S. Means there does not exist a retraction map from disk to S1 circle. Close disk to circle. So we can see that the proof of this theorem. So according to the definition of B2, disk is equal to B2 is equal to x belongs to R2 such that x is less than or equal to 1. Means B2 is a disk. We can define this as such that x comma y belongs to R2 such that x square plus y square is less than or equal to 1. Means closed disk whose radius is 1 and all shaded area inside and boundary is also included in this disk. And S1 is a circle. And S1 is a circle whose structure is x comma y belongs to R2 such that x square plus y square is equal to 1 means unit circle whose radius is 1. The whole boundary of this disk is unit circle. So we have to prove there is no retraction of B2 onto S1. So assume that on contrary there is a retraction from B2 onto S1, or we can say, or in other words we can say that S1 is retract of B2. Let's say inclusion map I. There is a retraction map from, according to contrary assumption, there is a retraction map from B2 onto S1. So the inclusion map, according to the definition of inclusion map, S1 is a subset of B2. So inclusion map from subset to superset, and I of S is equal to S for all S belongs to S1, according to the definition of inclusion map. So I is the map from circle to the closed disk. Inclusion map. This is inclusion map from mapping from S1 to B2. This is inclusion map. And the induced homomorphism map. Induced homomorphism map. Group homomorphism map. Isteric from I1 first fundamental group of S1 comma S0 is a base point to first fundamental group of B2 comma B0 is the base point of this. According to previous theorems, we saw that I is inclusion map from a subset to superset is injective map. If this is injective map, then I steric is the fundamental group homomorphism induced from inclusion map. I steric is also a not x not to first fundamental group to first fundamental group of x comma x naught. Here is base point a naught. A naught is the base point of this topological space. So this map, according to previous theorem, this inclusion map, this induced inclusion map from induced from this inclusion map is also injective map according to the theorem. So if According to our contrary assumption, R is the retraction map from B2 onto S1 and I is the inclusion map S1 onto B2, S1 to B2. I is inclusion map and I is also injective map according to the definition of inclusion map. So according to the theorem, I steric induced homomorphism map from induced from this inclusion map I1 first fundamental group of A comma A naught to first fundamental group of B2 comma S1 to B2 comma B naught is also an injective map according to the theorem. But if we see that if we see this statement, yeah, if this mapping first fundamental group of S1 into first fundamental group of B2, as we know that the first fundamental group of S1 is the isomorphic to integers and the first fundamental group of B2 is isomorphic to trivial set. So this is not a implies this is not a I is not a injective map because there is lots of integers, infinitely many integers, and here is 0, only one element. So there is no injection between this z to trivial this 0 means so our assumption R is the retraction map from B2 onto S1 is wrong implies there is no retraction bit from B2 onto S1. This is proved. Thank you. Assalamu alaikum.